Now, let's start with a new lesson 5 for medians and altitudes. Now, as I told you, we have 4 sets of the bisectors in triangles: perpendicular bisector, angle bisector, medians, and altitudes. We talk about the perpendicular and the angle bisectors. Today, we are going to talk about medians and altitudes. Let's start now with the median of a triangle. A median is a line that joins the vertex of a triangle to the midpoint of the opposite side. A line that joins the vertex of a triangle. And I need now to draw a line starting from the vertex. Where's the vertex? This is the vertex. Starting from the vertex, ending with the midpoint of the triangle. So what did I need to do? First, I need to ask myself, where is the midpoint of this side? It will be here. And the midpoint of this side, it will be here. The midpoint that cut the side into 2 equal parts. And the midpoint of this side, it will be here. After I did this, I will draw a lines now, starting from the vertex. Where are the vertices of the triangle? They are on the angles. So I draw a vertex, a line, starting from the vertex, ending with the middle of the center. And then I will draw another one from the vertex of the triangle, end with the middle. And then I will draw another one, starting from the vertex, end, and the middle of the lines. So this is what we call them median of triangle. Is it clear how can I draw the median?
Yes, Miss, the median of the sides, correct?
Yes, it's from its name, median. I need to draw where are the midpoint, the middle point. Then from the mid, I draw a line to the vertex. From its name, median. Yani I starting from the middle of a triangle. Now, they are the lines. These lines are intersect at a point. What we call this point? We call it centroid. What we call it?
Centroid.
Centroid.
Now, our theorem here, theorem 5.8. It says that the median of the triangle are congruent at a point. That is 2/3 of the distance from each vertex to the midpoint. What does it mean? That means if you have this triangle here, we have a triangle F, or D, E, F. So in this triangle here, as I told you, we need to draw the median. The median is from the midpoint ending with the vertex. From the midpoint ending with the vertex. From the midpoint ending with the vertex. These are the medians. Now, since we say that it is from starting from the midpoint, so the length of DH will equal the length of HF. And the length of JE is equal to the length of FJ. And the length of FG is equal to the length of GD. Because H, J, and G are a midpoints. All of these now, we know it before. Now, what our theorem told us? Our theorem told us that the length of DC, this one here, DC is 2/3 the length of DJ. Now, since D J, this is DJ. Now, they told me that at this point, or at this point of centroid, we have two lines. One of D is DC and then CJ. D, C, and C, J. Now, they prove it, then they found that if this is third, this will be 2/3. And they cut, yani DJ, you cut it into 3 parts. At this point, we have the centroid. So if this is, or if the length of DJ is 9, this will be 3, 3, and 3. So the length of D or of CJ will be 3. And the length of DC will be 6. So they prove that the length of DC, this is DC. Now, how can I know? Now, DC is on DJ, as you see. So the length of DC will be 2/3 or 2/3 the length of DJ, of the whole side. DC is 2/3 of DJ. And look at the second one now. Here, this is the second one. So which one is starting now? Okay, teacher. How can I know which one is equal to 2/3? Is it FC or CH?
No, Miss, it's CF.
Is it clear?
Yes.
Here?
أيوة miss. Yes.
Here now, I have this side, starting from the vertex, ending with the midpoint. Now, my theorem told me that the length of a line that is starting from the vertex, okay, from the vertex, not starting from the midpoint, starting from the vertex, the length of it, I means FC, will be 2/3 the length of the big one, which is FH. So if I have it here as F and C and H. So FC is a line on FH. This is the relation between them. FC is on FH, but the length of FC will be 2/3 the length of FH. Is it clear?
Yes,
Yes,
Miss.
I don't understand.
Right. Let's do now the third one in order to understand it. Here I have a side which is GE. This is what? This is a median. It's starting from the midpoint, ending with the vertex of the triangle. Now then, this is GE. So at this point, GE, what are the two lines on GE? Hi, GE. Sorry.
ACG.
Now, let's see, what are the lines on GE? We have G, C, and E. So GC and CE. Is it clear, Yara?
Yes.
We have this line, GC, and we have another line, which is C. Just a second, please. Which is CE. These the two lines now. Now, this theorem helped me to find a relation between GC and the big one, GE. Between this one, the small one, what's the relation between them and the whole side? Now, after the mathematicians proved it, they found that the length of GC is 2/3 the length of GE. the length of GC, the length of this side, is 2 over 3 the length of GE.
Miss, you mean the opposite AC is the 2/3 of the length of CG.
From where I drew it here. It is okay, صح. Sorry. How can I know? I have to see from where it starts. It started from here. This is my triangle. So CE is 2/3 the length of GE. This part is 2/3 the length of this part. Is it clear?
Yes, Miss.
Let's give you now another.
Yes.
Just a second here. I forgot this problem. I want now to draw a triangle for you here. Let's name it now with A, B, and C. I told you that it's named median, so it means that from the midpoint, I'll start drawing a line ending with the vertex. And from the midpoint, I will start to draw a line ending with the vertex. And here from the vertex ending with the midpoint of the line. These are what? These are the medians. From median, from middle to the vertex. Now, here we have X, Y, and Z. So then, here we have X, Y, and Z. And this point, let's name it with point P as an example. Now, my theorem told me that. Where are the relation between them? If this is AP, the line starting from the vertex, AP will be 2/3 of which line? Which line that its length is 2/3 the length of AP?
AZ.
AZ. This is AZ.
AZ.
Type XP. لا مش XP, sorry. I need now to name it from a vertex ending with the center or with the centroid. So CP is 2/3 the length of which side?
CX.
CX.
And then PB is equal 2/3 of which sides?
Of BY.
Bravo, B1. That's it. You have to look at the sides starting from the vertex. I mean this one, and this one. These three now, they have a relation with the side that they are on. And this part of this small segment have a relation, or it has a relation with the whole segments. Is it clear?
Yes.
Yes, Miss.
Now, let's solve problem number 1. Finding the length of a median. Here, as you see, we have a triangle. We have, its name is X, Y, and Z. We have a points C, B, and A. And we have a midpoint. Oh, لا, A is a midpoint, sorry. It is here. I can say A, B, C, and this is D as an example. Now, in the diagram at the right, if the length of XA is 8, what is the length of XB? The length of XA is 8. What did I need? I need to find the length of XB. Now, from our theorem, what is the relation between, before you start, ask yourself, is XA is on XB, the line segment XA, is it on the median XB?
Yes.
Yes.
So XA will be 2/3 of XB. XA is 8. 2/3 of XB. So what did I need to find? I need to find XB.
I'll multiply the reciprocal of
Yeah.
2, 3.
Bravo. So here, let's say that. Here I have 2/3. I need to cancel it, so I will multiply by its reciprocal. So it's cancelled. So XB will be 3. I can say simplify it here, divide by 2, divide by 4. So it will be 12. So if the small one is 8, here, if the small one is 8, the length of the bigger one will be 12.
And
What
Miss
is the length of
AB? 4. 12 minus 8 equals 4.
Bravo. That's it. So if I'm asking you about XB or AB, you can solve it. Is it clear?
Yes, Miss.
Yes, teacher.
Do you have any question?
No, Miss. Thank you.
Okay.
No.
Okay.
No, thank you.